Hi friends, today I would like to propose a new design for IR proximity or obstacle detecting sensor. The traditional sensor which is available in the market as shown in the figure, it is very cheap and it is available only for 30 rupees. But the problem with this sensor is it doesn't work properly in the sunlight. So I am going to propose a new circuit which contains a different IR sensor module. Here the traditional IR obstacle detecting sensor contains two IR LEDs, but this is not useful if your project works in the sunlight. So here is the new sensor which I have used in my circuit. The new sensor works at 38 kHz infrared frequency and the part number is VS1838B. This VS1838B as shown in the figure contains three terminals. The first one is output terminal from which we get the output signal. Second one is ground terminal and third one is the VCC terminal. The resistors should be connected appropriately, otherwise the sensor gets damaged permanently. This IR sensor module contains a pin diode, preamplifier, automatic gain control and band pass filter followed by demodulator and NPN transistor. Whenever the IR sensor receives the infrared light at 38 kHz frequency, the pin diode present in the sensor gets activated. After this, the signal from the pin diode goes to a preamplifier and also to automatic gain control. This automatic gain control will amplify the signal and it will send the output to a band pass filter. This band pass filter will filter out the unwanted frequencies and will send the output to a demodulator. This demodulator will activate the NPN transistor present at the output pin of this IR sensor. So finally, whatever the output signal which we are getting from this IR sensor comes from the NPN transistor. Now I am going to explain the transmitting and receiving stage of my circuit. So the transmitting stage contains two parts. The first part is 1 Hz astable pulse generator. In this 1 Hz astable pulse generator, I have used NE555 IC. The use of this 1 Hz astable pulse generator is, it's going to send a single pulse every second to the second stage. So this single pulse which is sent from the first stage to the second stage will switch on and off the second stage at 1 second interval. The second stage contains the IR emitter which sends signals at 38 kHz. So coming to the first stage as shown in the figure, it works at 5 volts. All the circuits which I have shown in this project will work at 5 volts. Do not power the circuit with more than 5 volts, which will destroy the circuit permanently. The NE555 which is shown in the circuit is working as a stable pulse generator and the values of resistance R3 and C3 are adjusted in such a way that we get pulse output at 1 Hz. So here as shown in the red letters, R3 I have chosen as 7.2 kilo ohms, C3 I have chosen as 100 microfarad, and for this with the output frequency formula, output frequency equal to 0.72 by R3 into C3, so we are going to get 1 Hz astable pulse. This pulse which is obtained from this first stage is sent to the second stage. Now I am going to show the second stage where IR beam is generated. This is the second stage of the transmitter. In this second stage, the infrared LED will generate 38 kHz pulse using the NE555 which is working as a stable generator. This circuit also uses 5 volt as the power supply. Whatever the output that is generated from the first stage, this pulse output which is present here as shown in the figure is given as input to the second stage as shown here. This second stage will take the pulse which is given by the first stage and this NE555 will send the 38 kHz pulse. But this 38 kHz pulse will be transmitted only for 1 second. After 1 second duration, the NA555 present in the circuit will switch off. It's because of the pulse input that is receiving from the first stage. The reason why I am doing this is we can use only second stage as the IR transmitter, but VS1838B is designed in such a way that when it receives the continuous 38 kHz pulses, it will control the AGC in such a way that the output will become low after certain period of interval, after which you again have to wave your hand to make the circuit work. But in my circuit, my desired goal is when I place a hand, the sensor should generate pulses continuously. So to make this work, I have used this first stage. This first stage will send 1 Hz pulse, and this 1 Hz pulse received by the second stage of the transmitter will generate 38 kHz pulses with 1 second gap. So whenever the pulses are sent with 1 second gap, the VS138B sensor will never get saturated and the output will be pulsing. Coming to the receiver stage. This is the total transmitter circuit which contains both first and second stages connected. So coming to the receiver stage, as I already mentioned, I have used the VS1838B IR sensor, and resistors are properly chosen in such a way that the sensor will not get damaged. Make sure that you apply only 5 volt to this circuit. If you apply more than 5 volts, this sensor will get damaged permanently. The output of this sensor is amplified using a BC557 PNP transistor, and a green LED is used for indication of the output which is received by the sensor. Even the transmitter stages also contains BC557B. So these transistors, which are PNPN, are used for amplifying the signal that is sent to the LEDs. Here is the demo of my circuit. Whenever I place my hand, the red LED will generate continuous pulses, and when I remove the hand, the continuous pulsing will stop. The green LED present in the circuit is the output of the first stage of the transmitter, and the red wire shown here is the output of the first stage getting connected to the second stage of the transmitter.